Senior high school, sir.
Okay, good. No? So most of you, inyong strand is technology, right? Tama ba?
Amag STEM. Namgoro sa
STEM,
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 sir.
STEM. How
Six.
about the others, no? How about sa physics?
Yung,
Did you hear these terms?
yung sir.
Wala? Okay, no? So, we will discuss. Okay, did you see my share screen? Tanan ba
Yes, sir.
nakaklaro? Okay, so if I write something, no, makita ba ninyo? Please confirm. Okay, I'm writing B plus A. Okay, makita ra? Anybody can confirm if nakita ninyo akong SWOT?
Oh, sir.
Okay.
Kita na,
Yes,
Okay,
sir.
sir. Yes,
great,
sir.
no? Sige. So let's start, no? So basically class, our discussion this afternoon is about current, charge, and voltages, no? This is the basic, no? Basic concepts in electricity and electronics, no? By the way, this class is adapted from the source that I've cited here, okay? So at the end of the class, okay, palihog lang kog mute, no? Para dili kay ta feedback, no? So at the end of the class, okay, students able to distinguish, no, current from charge, voltage, and resistance, no? Although resistance will be discussed in next meeting, no? So second objectives is that at the end of the class, okay, students able to analyze simple DC circuits, no? So that is the evaluation part, okay? So let's proceed with the second slide. Okay, so what is electric current, by the way, no? So for example, no, we have a wire here, no? So let's say this one represent a wire, no? So for example, this is your wire, no? So for a while. So if this is a wire, okay, a piece of wire, okay. So we know that wire, no, used to transmit electricity, okay. So basically, class, a wire is basically a neutral state, no. So meaning the electrons and protons within the material is neutral, okay. So when we speak of neutral, meaning it has an equal number of electron, no, and proton, no? So this is the basic part, no, of an atom, no. So because its materials is composed, no, are composed of different atoms or atoms, no? Numerous number of atoms, huge number of atoms, and as we know, inside the atom we have particles also, what we call electron and proton, no? So these are, I will not discuss that further, no, because this is already discussed in your physics and of course, no, during your chemistry, no, so which is another subject, okay. So current, okay, so since we are discussing current, no, as a concept, current is the rate of which electrical charge flow through the substance. So meaning kog current plus or kuryente, no, sa Binisaya, no, this is the rate, no. Palihog lang kog unmute, no, mute, no, palihog lang kog mute sa kuano para di ta madisturbo, no. Okay, so current is a rate which electric charge flow through the substance. So meaning rate, okay? So rate, yung kag rate, no? It's something to do with the magnitude, no? This is a vector quantity, no? So it has a magnitude and direction. So therefore, in order to understand electric current, we have to examine electric charge, no? For us to understand electric current, no, dapat we can understand, no, what is charge, no? So unsa din yung charge, okay? So charge, okay? Later, no, we'll discuss what is charge, no. So kaniha akong explain. Okay, we have here an electric charge, no. So mayong kag electric charge class. Okay, a material here, no. So for example, you have material or wire, no. So it has a proton represented by positive and electron represented by negative, no. So these are positive and negative charge, no. So mayong kag positive negative charge, we refer that one to proton and electron, okay. So in an atom, no, inside an atom, there are two particles. We call that P and E, or electron and proton. Okay. Okay. So basically, electron has 1.602 times 10 to the negative 19. No? That is the that is what we call the size, no, of a proton. No? Imagine negative 19. No? So similarly, electron also has negative. No? It has represented by negative 1.602 times 10 to the negative 19. No? So the unit of charge class, basically we refer this one as coulombs. No? So This is in honor of Mr. Coulomb, no, who discovered about charge, no. So basically, class, coulombs, no, or charge, no, represented by unit C or coulomb, it is represented a variable, no, may kag variable, no, a representation Q or big Q, no. So makakita mo Q nga gamay or Q nga dako, it refers to a charge, okay? So that is a charge, okay? So the unit of that charge is coulomb or coulombs, no, kung daghan. Okay, nakuha ra ninyo ang konsepto, no? So the concept initially is we have material, no? For example, a wire. So in that material, okay, it's a neutral state, so meaning it has the same number of electron and proton within it. Okay, so we have the size of a proton and electron, 1.602 times 10 to the negative 19. That's very small, no? Not a microscopic, more than microscopic, no? That number, no? So that is the unit of charge is coulombs, no? So saan na to pag-relate ning charge to electric current class, no? So this is discussed in the next slide, okay? So in the next slide, okay? So for example, no, charged particle exert on force, okay? So may kag charge, no? As I mentioned, no, a wire, a steady state wire, meaning simple wire, it has the same number of electrons and protons, or we call this one positive and negative charge, okay? So the charged particle exert on force and other charged particle, no? So the force per unit charge is called electric field. So meaning the 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 charge, no, for the what do you call this activity on it, no, in a material, no, let's say stable material or steady state, okay, we call that positive and negative charge or proton and electron. Initially, if it exert, no, so exert a force, no, because there's such a thing that we call this one exertion of force. We call that one as charged particles or electric field. Okay, so once the particle is charged, no, regardless of state, no, negatively charged or positively charged. So meaning class, may kag positively charged, there's what we call deficient in electron, no. So meaning there are more numbers of positive, okay, charge on it, no, than negative charge on it. Yung negatively charged also is the other way around, meaning there are a lot of electrons on it, no, than proton, no, or positively charged. So therefore, there's what we call electric field, no, or charged particle, no. Therefore, charge flow because their electric fields exert forces and pose each other. So meaning kuan siya class, no? There is inequality, no, the positive and negative charge. The tendency is that there's what we call particle, since charge ni siya, meaning that material, no, or matter or wire, for example, as I've mentioned kanina, there's what we call deficient in electron or proton, for example, for positive negative charge. So there's what we call forces acting on it, no, because there's no equilibrium on that, no. So we call that one as charged particle, no. So that charged particle, okay, the field on that is what we call electric field, okay. So yung call electric field, okay, electric field, diri na mosod ang electric current, no. Some the definition of electric current and what this one relate to charge, no. So electric current represented by I, okay, is the quantity of charge, okay. So quantity of charge represented by Q or small q that passes through a given area of a specific time, okay. So klaro kay na siya class, no. Current, okay, current, no. So current, okay. So by definition, okay. By the way, class, how's my audio? Klaro pa ba? Maklaro ra ko ninyo?
Klaro na, sir.
Okay, so
Yes,
by
sir.
this
Klaro na,
definition,
sir.
class, okay, so current, no, represented by I, is actually, okay, the quantity of charge, no. Pwede ni siyang Q na dako or Q nga gamay, no. Or pwede sa represented by small q, okay, over time, okay. Okay, so meaning the unit of this one is coulomb, okay, coulomb represented by C, and the unit of this one is second, okay. Okay, so second is siya class, no? For a while, no? Second, no? So, second, okay? second. Okay, so that is the definition of a current. So, sa relation sa current of charge. So, meaning a current only occurs when a particle is charged, no? Regardless of charge, no? Positive or negative charge, no? So, that quantity, no? That force, no? Because there's what we call in equilibrium, no? They are they are breaking each other, no? Because of in equilibrium, no? We call that one as electric field. Once there is an electric field, okay, there is what we call current, no? The current, okay, electric current is the quantity of charge passes through a given area. Mostly kaning given area atong gitawag is a conductor, no? Like wire, no? We use usually at home, no, to transmit electricity or energy from one point to the another, from MECO, for example, or BECO or SEBECO, from the outlet of your home, no, to your TV or let's say charger in a cell phone, no. So that amount of energy, no, electric field, okay, is in a form of charge, no, or kaning ginatawag natong charge, a unit coulomb, no, over time, no, the time, no, the duration, no, measured in seconds, no, that is what we call current. Okay, so let's proceed with the next slide. Okay, so the next slide, class, is basically the definition of current. No? So as I mentioned, no, current can be expressed in the derivative of Q over T, over dt. No? So, or in short, we can represent that current definition into this what we call equation. Okay, so this is the equation of the current. Okay, so when you are also what we call this one analyzing, no, complex current, no, we can use this definition. No, this is the differential equation, no, dq, first dq, the derivative of charge all over the dt. No, the dt basically is the difference of time. Okay, so we will focus on this one. No? We will not focus more on this, but we'll focus in this one. Okay? Okay, no? So, ha? Naklaro pa ba? Nakasunod ra ang tanan? Nakasunod ra class?
Yes, sir.
Sunod na, sir.
Nakasunod ra, no? Okay, no? So, okay, let's move to the next slide. Okay. So, for example, no? So, we have an example, no? Let's see if we really understand the concept, no, as I've discussed kanina, no. So for example, no, we have a 1 mm cross section of a copper wire, no. So most of our wire at home is made of copper, although there are also silver. Is isolated at 50 coulombs of charge flow through it in 2 seconds, no. The question is how much current flowed through the wire during that time. Okay. So, can we anyone who can guess the answer? Okay.
25.
What is that? What is one? The answer is, so for example, no, from that definition kanina, I equals Q, no? Q over T, no? Over T. And that Q, 50, no? That is 50 coulombs over 2 seconds, okay? 2 seconds, okay? 2s, and that is 25. 25. What is the unit? What is the unit again? So what is the unit of current, class? So the unit is amperes, no?
Si.
So I amperes na siya, class, no? So A is what actually refers to amperes, no? Amperes, okay? This is the amperes, or represented by big letter A. Okay, no? So I guess, no? So mga nakuha na ninyo, no? So pwede na mo sa atong evaluation later, no? Okay? So let's move on, okay, to another topic, no? Okay. Okay, no? So basically, no, by that definition, no, what are the different directions of flow of current, no? So kanina we mentioned naman, no? So positively charged or negatively charged, okay? So we will establish, no, the flow of current, no? So when a current flow from positive, no, positive to negative, so we call that one as positively charged, no. So mayroon kag positively charged, that the current, no, the current representation is plus, no. So what is the technique plus? Kung asa nagagikan ang current, that we will carry over the direction of that current, no. So in other way around also, if the flow of current is from negative to positive, for example, this is a battery, no. So sample battery na, no? Battery sa relo, battery sa kanang inyong wall clock, or battery sa inyong radyo, no. So if the current flows from negative to positive, no, we call that one as negative current, no. So negative current, no. So there's no issue of negative or positive, no, because that is the flow representation only, no. Okay, but sometimes, no, it is important, no, to understand, okay, the direction of the current for later, no, in the advanced topic, no, we'll be discussing basic circuit analysis, okay. So it is very important, no, that that concept, no. Okay, so positive current flows from positive to low, no, negative current, as a summary, flows from negative to positive, no. So as I mentioned, no? So electric current I, okay, which is the unit is amperes, okay, amperes or letter A. This is the quantity of charge, no, as I mentioned kanina, no. So basically these are the formula class, no. So these are the formula, okay. Never mind on this formula, no, because this is applicable to higher, no, higher higher analysis in electric circuits, no. So we just focus on this one, I equals Q over T, okay. So the next topic, okay, palihog lang ko mute, no. The next topic is voltage, no. So we discuss charge, we discuss current, and what is voltage, no. So unsa maning voltage, okay. So voltage class, okay. Remember the concept kanina akong i-present, no. We have positive charge and negative charge, no. So the lesson builds upon charge flow, no. That is current, no. Charged particle exert a force on other charged particle. So meaning voltage basically is a force, no? Okay? Basically is a force, no? This force per unit charge is called an electric field, no? So we have an electric field, okay? And the unit of that electric field is current, and the force exerting on that is what we call voltage, okay? So charge flow, because there's electric field, exert forces that pose each other. So meaning, if we're going to analyze this definition class, okay, the electric field, okay, measured in current, no, or I, okay, and the force exerting on that one is we measure that through the voltage, no, or volt or voltage, no, voltage na siya class, okay. So mura na siya tubig, no, when I was a student like you before, no, so gikuha ni siya ba mura siya tubig, no. So ang tubo ko, no, ang tubig class is what we call electric field or current, no. Pero ang puwersa, no, pressure na nag-exert to deliver the water to your households or to your mga gripo is what we call voltage, no, measured in a pressure, no. So mo na definition. Palig lang ko mute, no. Okay, so that is the definition of voltage, no. So here, okay, we will have the what we call this one, the formal definition of voltage. So, something voltage class. So we have here a material, for example, the cross-sectional area of material, and we have this charge. No, let's say this material is positively charged. That's why you see two positive, no, two positive proton. No, when moving through an electric field, the charge either gains energy or loses energy. No, charge loses energy when moving in the same direction of the electric field line. Okay, so of course, no, because of that movement class, it produces heat. Okay, and remember, heat is also an energy. No, so that's why we have what we call losses of energy when there's what we call transfer of energy. No? So this in electric, okay, electric field, we heat, that losses represented or through heat dissipation. No? So heat, okay, is actually an energy. No? It's just a conversion of from electrical energy to heat energy. Like your kanang inyong mga kuan, no? Like your si tawag ani kanang inyong mga electric iron or even suga, no? Even suga, no? So that heat converted into light, no? So that light, no? And eventually lights up your kuan, no? Your room, for example, during the night time. Okay? So okay, kalas, nasundan pa ninyo, no? Nasundan pa ba ko ninyo? Nakasunod pa
Yes,
ang
Yes,
sir.
tanan?
sir.
Okay, great, no?
Yes,
So,
sir.
okay, great, no? So, how do we calculate voltage, no? Voltage class, or represented by V, no? The unit of voltage is volt, no? Is the charge or in energy, okay? May kag energy, that is W, no? Per coulomb of charge, okay? So, if we're going to to convert that statement into equation, so this is the equation. Voltage is equal to dW over dQ. D represent D here is what we call the representation of uh, derivative, no, derivative, no. So okay, so but we're not again, no, we're not what we call this one um, focusing on this equation because this is for higher, no, higher higher analysis, no, but we focus more on this equation. So energy over charge, okay? So energy, no? So energy is watt, no? And what is watt? By the way, watt is equal to what?
V.
Watt or
One.
P is equal to
Arch.
I. That is the current times voltage, no? So that is the translation, no, of energy. So and we know charge is the unit of that one is coulomb, okay? And what is charge, by the way? What is coulomb, by the way? Okay, coulomb or Q, no, or Q.
Arch.
Okay, Q is equal to, at sa ganun Q is equal to I over T, over T,
T.
no? So
T.
this is from the equation I equals to Q over T. We just transpose those equation that come up with this equation. Q equals to I over T. Okay, so nakuha ra, nasabtan ra. Is there any question on the derivation, particularly where we get this one and this one? Okay, sabtan ako ninyo. I hope
Yes,
nakuha ra
sir.
sa tanan, no?
Yes,
Sige.
sir.
So we'll proceed with the next slide. Okay. So here is the next slide, no? So for example, no? So we have a voltage here, okay? Calculate the voltage here, okay? So from point A to point B, no? So BAV is the energy lost per unit charge as the charge moves from A to B, no? BBA, by the way, is the energy gain, no? So because the point of intersection class is here, okay? Okay, since the point of intersection is from here, here, okay, dire, okay, dire, okay, so to here, so meaning the movement of that one, there's what we call energy lost, no? So energy lost, no? Because there's what we call transfer of energy. But um, when our reference is the other way around, okay, B to A, because there's what we call gain, no? Nganong gain man? Because the original position of this charge, no, kani silang duha, is from A, no? So of course, no, B is zero initial, so there's what we call gain, okay? So let's compute this one, no? Quiz first. So here we have what we call 4 coulombs of charge lost 20 joule of energy when moving from A to B. What is the voltage, no, or VAV? Okay. So so we have this unit, no, joule. Okay, what is joule, class? Joule. Okay, okay. So maybe I will present this one. Joule. Okay. Unsa ganitong kuan? Unsa ganitong current, class? Current. I. Okay. Unsa ganito unit sa I? I
I
equals to
equals Q.
Q, and the unit of Q
I equals
over
Q over
T.
over T.
And the unit, this one is coulomb per second. So we call this one as amperes, no? Amps, okay?
Amperes.
Amps, okay, amps
Amperes.
or amperes, no? Or A. But what is J? J, voltage, class, is actually equal to joule per second, okay? So joule per second is actually 1 volt. So here we have this equation. Uh, what is the voltage? No, voltage equals to 21 joule. Okay, 21 joule. Mayroon kang 21 joule. This is an energy over 3. Tama ba? No, not over. No, sorry ha. This is not 21. No.
20.
Here pala no.
20.
Here pala no.
20.
4 no. 4.
20, sir.
Once again, 4 coulombs no. 4 coulombs no. 20. Sorry ha. 20 20, okay, the unit of that one is joule over
Joule.
4
For
coulombs, okay? Okay, 4 coulombs, okay? So, what is the unit then? That is actually, pila man eh? 20 over 4, that is 5
5 volt.
volts,
Volts. 5.
okay? By the way, no, joule over coulomb is actually volt, okay? So, joule over coulomb is actually volt, no? So, how about this one? So here, voltage equals to 21
Equals 71
joule over
over 3 plus 3.
coulomb. Okay. What is the answer?
21 ay 7, sir. 7
7,
volt.
7.
7 volts.
7 volt.
Okay. So namin nalimtan, no? Because that energy required to move from B to A, remember this one, B to A. Okay. So B to A man siya, class. So that is negative. So negative meaning that charge moves from A to B. That is gain. No? Once we call this one negative, kanina, remember kanina,
Electron.
we represent this one negative, there's what we call gain. No? Here, this is positive. No? So meaning these
Positive.
are the lost energy, no, from this representation here. So look at this representation. So negative siya, no? Volts, no? Negative volts, 7 volts. No? Okay, so I hope it's clear to everybody na. Okay, no? So let's move to next slide. So we're almost done, no? So basically, class, voltage is always measured from reference point, no? Kanina, no? I mentioned kanina, no? So as an analogy, consider a mountain, for example, no? In order to measure the height of the point A in a mountain or on the mountain, we must define the reference point, no? So that's the definition. Similarly, also, in order to measure the voltage at point A, in a circuit, for example, we must define the reference point. No? So kanina, no, we define this the reference point, no, from A to B, no. That's why we have positive 5 and negative 7, no. So if you notice last time, so the reference point is only affects our measurement, not the actual direction of the electric field that causes the voltage drop or increase. Okay, so ang kanang reference point na to, class, it has something to do with the convention, no, katong negative or positive, no, but the magnitude, which is 7 or 5 kanina, as discussed on the example, no, it has nothing to do with the reference point. Okay, so to fully understand, no, the reference point, no, of aqua, no, consider we have this battery, for example, no. So we have 1, 2, 3, 4 batteries connected in series. No? So the question is that, okay, consider this is a mountain daw, no, analogy na to. Consider we have this one. For example, no, the current, no, because this is already only a battery class, no, battery, there's what we call magnetic field on it, no. So if a battery of the current, no, travels from point A, B, C, D, then back to A, our voltage is not changed. No? Of course, it's not changed, but we're going to distinguish the resultant, no, the resultant of that, no, at the point C, no, point A, for example, no. So from point A, for example, we have, let's say here, no, because that is point C, for example, we have 6, okay. So remember, no, remember class, we're going to track back, no, from D, no. So for example, D to, or asam ta mag-start class 3, arita sa 3, no, from, or regardless of asa ta mag-start, no, because it has nothing to do with it has nothing to do where we start, but we're going to check, no, the direction. For example, we're going to here in this example, no, okay, sorry, no, ako sa ning reason class ha. Here in this example, look at this example class. Okay, we have this what we call, we have this 6, no, asa man ang 6, why we consider that one 6 is a negative, so meaning down, no, because 6 here, no, diri siya nagagikan, no, diri siya nagagikan, no, so 6 here, so we call this a negative 6, okay, for kuan siguro, no, para di ta maglibog, no, so ato na lang ning reason, no? So 6 here, okay. So we go back to the convention. Remember kanina how we define that convention? Kani class ba? Kani ba? So meaning if the current leaving, no, to negative, we call that one negative 1, okay, or negative 1. And entering positive, we call that one as negative, no. If gikan is positive, entering negative, we call that one as negative current, okay? So negative current. For example, here 6, okay? We have 6 here, okay? 6, okay? Paana ta class? Gikan ta sa B, ha? Sa dire sa node B. For example, gikan ta here node B. So negative plus positive, so we call this one as plus 6, di ba? Di ba? That is our convention, right? And then we're going to this D, node D, no? So 3, no? So negative to positive, what is the unit of 3? Negative, positive.
Negative, sir.
Negative, no?
Negative,
Here,
sir.
for example, no? Sorry, no? So it should be negative, no? This one also is negative, no? Negative 3, okay? Negative 3.
Oh, negative 3.
Okay, here from going to A, 5. So, plus 5, di ba? Kaya gikan siya sa plus, no? This area,
Positive.
plus 5, tama ba?
Yes, sir.
Plus
Sir.
5. And then here also, gikan siya sa 4,
Positive 4.
plus
Positive.
4. Okay, 4. And then, balik ta sa 6. Okay, so, what is the result? Negative 3.
Negative 9.
Ha?
It is
What is the result?
18.
Plus
What is the
Zero.
result?
Zero, sir.
Ha?
Zero.
0. So, meaning, at any point class in this node, no,
Positive.
the algebraic sum of voltage at any node, no, C, A, D, A, B is equal to 0. So that is actually the concepts of Kirchhoff's voltage law, no, which is another discussion in our circuit analysis. Okay. So in this afternoon, no, the remaining time, we have still 1 hour to go, no. So we still have 1 hour. I want you to answer, no, your assignment, no. So I want you to answer your assignment, no. Dahil lang, ha.